In this lesson, you will learn more about Ansys Rocky and Ansys Mechanical coupling capabilities. Besides the amazing DEM and SPH features that Ansys Rocky brings to many applications, the couplings with Ansys Mechanical provide a more comprehensive simulation. While mechanical software is great for structural analysis, Rocky software specializes in particle flow simulations and granular analysis. By integrating both, you can understand system behavior, especially in applications involving complex interactions between solid structures, granular materials, and fluids. This is crucial in mining, materials processing, pharmaceuticals, and other areas with significant interactions between solids, particles, and fluids. The Rocky mechanical couplings capabilities are one-way structural with both static and transient structural, one-way thermal with transient thermal, two-way structural and thermal using system coupling. Here we have two examples of coupling applications. For the one-way structural coupling, an excavator application case. Bucket excavator interaction with DEM particles using Rocky appears on the left, and the mechanical transient structural analysis of the bucket stresses appears on the right. For the two-way thermal coupling, a heat exchanger pipe case. The SPH temperature using Rocky is demonstrated on the left, and the mechanical heat flux results being post-processed using Ansys Insight are demonstrated on the right. First, let's learn more about Rocky mechanical one-way structural couplings. These coupling provide the ability to send DEM SPH forces from Rocky to calculate stresses, strains, and displacements using mechanical for both static and transient analysis. They are executed through the Workbench application, which can handle Rocky and mechanical at the same time. We will show you these capabilities in a hands-on video using Rocky tutorials 12 and 15. You can download the files directly at Ansys Help. The first one-way Rocky mechanical structural coupling example uses tutorial 12, which is a static structural case. We need to link both the Rocky particle dynamics and mechanical static structural systems inside Workbench to make this coupling happen. After that, we can go to the Rocky setup. When coupling both, Rocky will identify automatically that it needs to export the DEMSPH forces to mechanical. So we'll need to access the wall loads option inside of external coupling. Then, we'll select the walls to participate in this coupling, as well as the load type, being forces or pressure, and then the domain range, where we can select the range of the data that will be sent to mechanical. For this tutorial, we are creating an output variable of the Y forces to be compared to the mechanical forces later. For this coupling, the rest of Rocky's setup will be the same as usual. After the case is fully solved inside Rocky, the mechanical setup will follow a regular mechanical workflow. However, we will need to add forces or pressure inside the imported load option. Note that when working with forces, mechanical will import the data automatically. Finally, we'll solve and post-process the stresses, displacements, and other properties of our liking. For the one-way Rocky mechanical transient structural case, we will demonstrate Rocky tutorial 15. Equally to what we did earlier, here we will also need to link both the Rocky particle dynamics and mechanical transient structural systems inside Workbench. The Rocky setup follows the same steps that we did for tutorial 12. The difference here is that we add an input variable to make it available to parameterize inside Workbench, which is the belt speed of the conveyors. Inside external couplings, we select all for the domain range force options to send all forces to mechanical. After the Rocky case is fully solved, we go to the mechanical setup. Here it also follows the mechanical workflow per usual, but once again we will need to add forces or pressure inside the imported load section, following what was selected to send from Rocky. Remember that forces will still be automatically imported for the transient structural. Finally, we'll solve it and post-process the stresses, displacements, and other properties of our choice. As shown in more detail in the tutorial documentation, it's possible to work with parameterization within Workbench using the parameter set function for both static and transient cases. On the left, we can see Rocky's mass flow rate as an input parameter, and both Rocky's force and Mechanical's force reaction as output parameters. On the right, we can see the design points table, where more design points can be added and the input parameters changed, creating new simulation setups and a parameterization workflow. This provides more efficiency and control for analyzing, in this example, the impact of mass flow rate on structural behavior. In the next section, let's learn more about the Rocky Mechanical one-way thermal coupling. Like the one-way coupling, the thermal coupling enables you to send the heat transfer coefficient HTC data calculated using Rocky to mechanical transient thermal, which can calculate the exchange solid thermal process. This coupling also uses the workbench. Note that as this coupling sends the HTC data, it needs to be used in a smoothed particle hydrodynamics (SPH) case. Let's see a practical example of this thermal coupling. After coupling the Rocky system with the transient thermal inside Workbench, the SPH heat transfer coefficient calculator module is enabled inside Rocky, as well as the HTC inside the external coupling tab, which enables the domain range and the reference temperature for the SPH data. After running the case in Rocky, the setup on the transient thermal side is the same as for the structural coupling, but the import load process will differ. The convection coefficient will need to be inserted, and the HTC data will automatically be imported as the forces data from the structural couplings. Then we'll need to set the faces for the HTC to be applied to. The temperature and other properties from the transient thermal capabilities can be post-processed inside Mechanical. In the last section, let's learn more about the Rocky Mechanical two-way structural and thermal couplings using the system coupling software. Different from the one-way Rocky Mechanical couplings using just Workbench, this two-way thermal coupling uses the Ansys system coupling software to handle the Rocky Mechanical data transferring process. The setup process of the two-way thermal coupling is pretty simple and starts from Rocky's side. We will use the system coupling wall in the place of a traditional wall, which can be imported or be converted from an existing one. After the system coupling wall is available, we need to set the coupling type to thermal. The rest of the Rocky setup will be done as usual. Note that this two-way thermal coupling supports both DEM and SPH. The final step for the Rocky setup will be to export the Rocky information to a SCP file, using the Right System Coupling File option in the File menu, which will later be used by system coupling. In the mechanical side, the transient thermal system needs to be used for this coupling. The setup follows common thermal-mechanical steps, with the addition of a system coupling region to be coupled with the system coupling wall of Rocky. After the transient thermal setup, we will select Right System Coupling Files, which will export the mechanical information to an SCP file, as it was done for Rocky. For the system coupling setup, we will need to select a folder to save the coupling files, and then add both the Rocky and the mechanical SPC files through the Add Participant option. Next, we need to add coupling interface, which will set both system couplings walls and regions and connect them. Then, we will select the Add Thermal Data Transfers, Heat Rate option, which connects the temperature data from mechanical to the heat flow from Rocky automatically. Finally, we can set the end time and the time step size to run the simulation. For the end time, it must be the same as the time for mechanical and the simulation duration for Rocky. And for the time step size, could be equal to the mechanical time step and the Rocky time interval. It's possible post-process the results using EnSite or OpenRocky to post-process it, where the new temperature option for the system coupling wall will be available. And to finalize, the setup process of the two-way structural coupling is the same as the two-way thermal. For the system coupling wall inside Rocky, it's now necessary to select what coupling will be done, in which the type chosen will be the structural. After setting the system coupling wall and following a regular Rocky setup, we use the Right System Coupling file, as done in two-way thermal. In the mechanical side, the transient structural option needs to be used for this coupling. The setup follows regular structural mechanical steps, with the addition of setting the system coupling region to couple with the Rocky system coupling wall. An important detail in mechanical is to pay attention on the time step, which might need to be more refined in some cases. Since we have forces being received by Rocky, which is an explicit solver, mechanical needs a large number of steps to be able to compute the incremental displacements. After the transient structural setup, we will select Right System Coupling Files. The setup for the system coupling side follows the same as for two-way thermal coupling, now making available the displacement properties to be post-processed inside Rocky, but for this two-way structural, it will have the force and incremental displacement for data transfer. The post-processing capability in both Ansys and Rocky also maintains the same as for two-way thermal coupling. We can also open the thermal and structural results directly in Ansys by opening the RTH thermal or RST structural files that were written by Mechanical. Be sure to watch the other 3 videos in this couplings course. By integrating Ansys Rocky with other powerful Ansys software, you can make the most of multi-physics simulations.